I see a 3x3 grayscale image represented as a NumPy array. This means we have a 3x3 grid of numbers, each number representing the pixel's intensity. The numbers are arranged like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. This image will be used as the input for the grid_to_graph function. This is a function from scikit-learn that converts a grid, like our image, into a graph data structure. The inputs n_x and n_y define the dimensions of the grid, in this case, 3 rows and 3 columns. The output is a graph where each pixel becomes a node and connections between neighboring pixels are represented as edges. This refers to the graph that we'll get after using grid_to_graph on the 3x3 image. We'll analyze its properties, whether it is directed or undirected, the number of nodes, if it is complete, and edge weights, to answer the quiz questions. The goal is to figure out the characteristics of the graph created using scikit-learn's grid_to_graph function with a 3x3 image. Specifically, we need to determine if it's undirected, how many nodes it has, if it is a complete graph, and the weight of a specific edge. This asks whether the connections between nodes in the resulting graph have a direction. In an undirected graph, connections are bidirectional. This tests if I can calculate the total number of nodes in the graph based on the input image size, 3x3. This checks if I know what a complete graph is. A complete graph has edges connecting every single pair of nodes. This tests if I understand how edge weights are assigned in the graph output and whether the edge between the first 2 pixels in the top row has a weight of 1. I have a 3x3 grayscale image. Each number represents a pixel's brightness. I'll use scikit-learn's grid_to_graph to turn my 3x3 image into a graph and analyze what I get. The question sets up the problem. I'm given a function, and I need to understand its output when applied to my image. I'm using a 3x3 grayscale image. Think of it as a 9-pixel picture. Each pixel has a number value. This is a function from scikit-learn. I use it to build a graph from the image. It's like making a map of how the pixels are connected. The graph shows which pixels are next to each other. I'll have 9 points, nodes, representing pixels. The lines, edges, between them show which pixels are neighbors. The connections between pixels go both ways. It's not a one-way street. If pixel A is connected to pixel B, then B is connected to A. The connection between the top left pixel, 0, 0, and its right neighbor, 0, 1, has a strength of 1. It's like saying they're directly next to each other. I have 9 pixels in my 3x3 image, so my graph has 9 points, nodes. It's a 1-to-1 match. That's easy peasy. Nope. A complete graph connects every single node to every other node. That's not the case here. Only neighboring pixels are connected. I see you have a 3x3 grayscale image. That means you have a square image with 3 rows and 3 columns of pixels. Each pixel has a single grayscale value, a number representing its brightness. We're using scikit-learn's gridtograph function to turn this image into a graph. The question is, what properties does this resulting graph have? I'm checking if the connections between points in the graph go in both directions or only one way. An undirected graph means connections work both ways, like a two-way street. I'm checking how many points or nodes are in the graph. Since the image is 3x3, the graph should have 9 nodes, representing each pixel. I'm checking if every node is connected to every other node. In a 3x3 image, a complete graph would have far more connections than are actually present in this graph. I'm checking the weight of the connection between 2 specific nodes, the pixel in the top left corner and the pixel next to it to the right. The weight typically represents the distance or similarity between nodes. I'm analyzing the gridtograph function's behavior to determine the characteristics of the generated graph. It's all about understanding how the function translates the image's structure into a graph structure. I'm analyzing the characteristics of the graph generated by gridtograph based on the 3x3 image input. I'm figuring out if the graph is directed or undirected, the number of nodes, whether it is complete, and the weights of connections between nodes. I'm asking you to determine which statements correctly describe the graph structure generated by applying grid to graph to a 3x3 grid. Let's break down each statement one by one. This statement focuses on a specific edge and its weight. 0, 0, represents the top left pixel, and 0, 1, is its immediate right neighbor. The grid to graph function, by default, assigns a weight of 1 to edges connecting adjacent pixels, reflecting their spatial closeness. So, this statement is true. Checking if you understand that the connections between pixels are symmetric. In an undirected graph, a connection from pixel A to pixel B implies a connection from B to A as well. This is how grid to graph works. It creates an undirected graph. Let's figure out the number of nodes. A node in this context represents a pixel in the image. With a 3x3 grid, you have 3 rows and 3 columns, resulting in 3 times 3 equals 9 nodes. We're going to analyze how the grid to graph function from scikit-learn creates a graph representation of a 3x3 image grid. The function builds a graph based on the adjacency of pixels, showing how they connect to one another. I'm analyzing how the scikit-learn function gridtograph creates a graph from a grid. I'll focus on understanding the resulting graph's properties. This question asks you to determine which properties correctly describe the graph produced by gridtograph when given a 3x3 grid as input. This function takes in the dimensions of the grid, 3 rows and 3 columns, to build a graph. We start with a 3x3 image, which means that we have a 3x3 grid. We use gridtograph function to build a graph out of this grid. I'm calling the gridtograph function with nx, number of columns, equals 3 and ny, number of rows, equals 3. This tells the function to create a graph representing a 3x3 grid. Statement A says the generated graph is undirected, meaning connections between points go in both directions. I need to determine whether gridtograph creates this kind of graph. Statement B claims the graph will have 9 nodes. I'll check if that matches the size of our input grid, a 3x3 image, 3 rows * 3 columns equals 9 nodes. Statement C suggests the graph is complete. Every node connects to every other node. I need to find out if gridtograph produces such a highly connected graph. Statement D focuses on a specific edge between nodes, 0, 0, and 0, 1, checking whether its weight is 1. I'll verify how gridtograph assigns edge weights. The final output is a graph. I'm interested in verifying the structure and properties of this resulting graph based on statements A, B, C, and D. I'm analyzing how scikit-learn's grid to graph function works. It's a tool for creating a graph from an image, representing the connections between pixels. This analysis is key to understanding how the function creates a graph structure from an image, focusing on the graph's properties like directionality, node count, and edge weights. We're given a 3x3 grayscale image and asked to determine the properties of the graph that grid to graph creates from it. I'll explore whether the graph is directed or undirected, how many nodes it has, if it's a complete graph, and what the edge weights look like. This is going to be fun. I have a 3x3 grayscale image represented as a numpy array. Each number represents the pixel intensity. The array is 1, 2, 3, 4, 5, 6, 7, 8, 9. This image will be the input to our grid to graph function. This is the specific 3x3 grayscale image data I'm working with. Each number represents a pixel's intensity. The function will use this to determine connections in the graph. It is the visual data that forms the basis of our graph. I'm calling the grid to graph function with n_x number of columns, and n_y number of rows, both equal to 3. This means I'm creating a graph representation of a 3x3 grid. The output will be a graph representing the pixel adjacency. I'm analyzing several properties of the graph. Is the graph undirected? Does it have 9 nodes, 1 for each pixel? Is it a complete graph, every node connected to every other node? What are the edge weights, the strength of connection between nodes? I will analyze these properties one by one. To learn more about graph properties. After my analysis, I've determined that the correct answers are A, B, and D. A indicates the graph is undirected. B indicates it has 9 nodes. D indicates that the edge connecting 0, 0, and 0, 1 has a weight of 1. These are my conclusions. I'm analyzing how the scikit-learn function _grid_to_graph creates a graph from a grid. This function is useful for representing images as graphs where each pixel is a node. I'll focus on understanding the structure of the resulting graph, not on the image data itself. This question asks you to determine which properties hold true for the graph generated by _grid_to_graph when using 3 rows and 3 columns as input. It's a multiple-choice question testing your understanding of how this function works. This describes a 3x3 grayscale image as a NumPy array. Each number represents a pixel's intensity. It's the input data that _grid_to_graph will use to generate its output graph structure, although the actual values aren't directly important for the question. This is the 3x3 image represented as a matrix. Each number represents a pixel's intensity, grayscale value. Again, the pixel values aren't directly relevant for this question. The question focuses on how the function converts this grid structure into a graph. This statement claims the resulting graph has 9 nodes. Because the input is a 3x3 grid, and each cell will map to a node in the graph, this is indeed true. This statement indicates the graph's edges don't have a direction. That is, if node A is connected to node B, then node B is also connected to node A. I find this to be true based on how _grid_to_graph operates. This statement proposes that every node is connected to every other node. This is false, because _grid_to_graph only connects each node to its immediate horizontal and vertical neighbors, not all nodes. This statement specifies the weight of an edge between 2 adjacent nodes. Given the default behavior of _grid_to_graph, this is true.